Hello, and welcome to this presentation, Analyzing UART with the RTM3000. This presentation will explain how to decode UART data using a Rohde and Schwarz RTM3000 series oscilloscope. In addition to basic oscilloscope skills, this presentation assumes a general familiarity with both serial protocols in general and UART in particular. If you're unfamiliar with these topics, or if you need a brief refresher, you might want to watch the presentations Understanding Serial Protocols and/or Understanding UART before beginning this presentation. We'll start by describing the physical connections to the RTM. The UART serial protocol uses separate wires for transmit and for receive. Each direction of the UART connection requires a separate channel and passive probe. In this presentation, we'll only demonstrate the setup for a single direction. Remember that in addition to connecting our probe tip to the UART transmit or receive conductor, we also need a shared ground connection. To enter protocol mode on the RTM3000, we can either choose Protocol from the menu or use the Protocol hard key. The next step is to choose UART from the list of available bus types. Every serial protocol has different parameters that need to be configured, so let's go over what these are for UART. We'll start with defining which channels are being used. Remember that we would need two separate channels to monitor both receive and transmit simultaneously. The next step is defining voltage thresholds, in other words, the level that separates ones from zeros. We can enter this manually, or we can use the Find Threshold button and ask the scope to try to figure this out automatically. Note that for Find Threshold to work, you need to press this button during a frame, so if the frame rate is low, you might have to press this button multiple times before a working threshold is found. An incorrect threshold setting is one of the most common problems when performing serial decodes. The next step is specifying the frame parameters, the bit or baud rate, the number of data bits, the number of stop bits, and parity. These must match the transmitter configuration exactly. For example, here we've configured 9600 baud, 8 data bits, 1 stop bit, and no parity. A few additional notes before we leave this screen. Idle time sets the minimum time between two frames. The high-low toggle inverts the polarity of the bits. For example, if we wanted the idle state to be low instead of high, we would switch this to low. The important thing is to be sure that the frame parameters we configure here match the parameters of the UART device. Now that we have all of our parameters configured, we can simply enable decode and see the decoded bits and frames. Display setup can be used to change the way that these bits are presented, as binary, hex, decimal, octal, or ASCII. Here, the actual measured voltage levels are shown in yellow, the decoded bits are shown in blue, and the ASCII decode of these bits is shown directly on the screen. In many cases, we want to see entire frames decoded or multiple frames decoded, and this can be done using the bus table. Enabling the bus table gives us a list of decoded frames over the capture window duration. Here, our horizontal scale is 50 milliseconds per division, so the bus table shows us all of the frames that were decoded during our capture window of 50 times 10 or 500 milliseconds. In this example, we see 8 frames during our window, and each of these is decoded, along with their respective start times, in the bus table below. We can also save the contents of the bus table to a file for analysis or documentation. In addition to setting the threshold correctly, one very important parameter when performing serial decodes is the capture window time. In our previous example, the capture time was set long enough to capture several entire frames. If the capture time is reduced too far, we can end up with truncated frames and incorrect or incomplete decodes. It's worth repeating that setting the capture window time is crucial in getting good serial decode results. Let's end with a brief summary. The RTM3000 can be used to decode many serial protocols, including UART, with a separate channel and passive probe needed for each direction of the UART connection. There are a number of important parameters that need to be configured. These include the threshold, which defines which voltage levels represent 1 and 0, and the capture window time, which defines the duration over which the signals are captured and decoded. Both of these are critical parameters, so it's important to be sure that they're both set correctly. Naturally, we also have to specify common UART parameters, like the bit rate, number of data bits, the presence and type of parity bits, and how many stop bits we have. We can choose to display the acquired bits either as raw bits or in other formats, such as hex or ASCII, and we can easily store or export the decoded data. This concludes our presentation, Analyzing UART with the RTM3000. If you'd like to learn more about serial protocol data and how this data can be decoded and analyzed, please see the links in the video description. Thanks for watching.